Earth does not need to burst into flames to become dangerous. Sometimes, just a few extra degrees can change how life works. Not because life is weak, but because life is carefully tuned. Every body, leaf, city, ocean, and ecosystem has a limit. So when Earth gets hotter, what actually starts breaking first? This is not a story about the planet suddenly exploding. It is a story about invisible limits slowly being pushed too far. Life survives by staying inside certain ranges of temperature and water. Heat moves those ranges across land, oceans, seasons, and cities, and many living systems cannot move or adapt fast enough. To understand the problem, imagine Earth as a giant bathtub. Sunlight pours in from above like water from a faucet. Then Earth releases heat back into space like water through a drain. For thousands of years, that balance stayed comfortable enough for civilization. But humans have partly slowed the drain without meaning to. We did not create heat from nothing, and the sun did not suddenly attack us. The real problem is that more heat now stays around longer. That is the simple, hidden mechanism behind global warming. More energy gets stored inside the climate system instead of escaping. And stored heat begins pressing on every living thing. The greenhouse effect itself is not a bad thing. Without it, Earth would be much colder and harder to live on. The problem is adding extra blankets faster than nature can adjust. Carbon dioxide is one of the main extra blankets. Methane is another powerful heat-trapping gas, even in smaller amounts. These gases still let a lot of sunlight come in, but they catch part of the heat trying to leave, so Earth can no longer cool itself at the same speed. A tiny delay sounds small until it happens across the whole planet. Climate is not one hot afternoon or one strange summer. Climate is the long-term balance of energy, water, air, and life. When incoming energy beats outgoing energy, heat starts to build up. The air warms first because that is where we feel it. But most extra heat does not stay in the air. The ocean absorbs a huge amount of it, like a giant thermal battery. That makes warming feel slower, but also makes it deeper and longer lasting. Once the ocean stores heat, it can release effects for decades. Land warms faster because soil and rock cannot mix deeply like water. Dark roads, roofs, and bare ground absorb sunlight extremely well. Bright snow and ice do the opposite by reflecting sunlight away. But when ice melts, darker water and land appear underneath. And darker surfaces absorb more heat instead of sending it back. So warming can create conditions that cause even more warming. This is called a feedback, but it is not magic. It is just a small push turning into a larger response. That is why a few degrees can matter so much. To human ears, 1 or 2 degrees sounds tiny. But Earth is not a bedroom with a simple thermostat. It is oceans, forests, clouds, ice sheets, farms, and cities. A global average also hides what people actually experience locally. Some places heat far more than the global average number. And heat does not arrive politely, evenly, or conveniently. It arrives as long nights, dry soils, warm oceans, and heavy pressure. The first thing heat breaks is comfort. Then it starts breaking concentration, work speed, and daily routines. After that, health risks can rise very quickly. The human body is basically a walking cooling system. It moves heat from inside the body toward the skin. Then, sweat carries that heat away as it evaporates. But sweat only works when the air allows evaporation. When air is hot and humid, the body gets trapped inside itself. That is why humidity can make a heat wave much more dangerous. The scary part is not only the temperature on the weather app. It is whether your body can actually get rid of heat. First come exhaustion, dizziness, headaches, and confusion. If the body keeps overheating, organs can begin to fail. So humans break before streets melt or buildings collapse. This is why shade becomes more than something nice. Shade becomes infrastructure, almost like a road or a bridge. Water becomes protection, not just a drink for comfort. And air conditioning becomes survival for some people during extreme heat. But this creates an unfair gap between people. Some people can buy cooler air, stronger homes, and safer routines. Others must work outside, travel farther, or sleep in hotter rooms. So heat becomes more than a weather problem. It becomes a health problem, a money problem, and a fairness problem. Cities make this unfairness easier to see. Concrete and asphalt drink sunlight all day like dark sponges. At night, they slowly release that heat back into the air. Tall buildings can trap hot air in narrow street canyons. Cars, machines, and air conditioners add even more waste heat. Trees do the opposite of concrete. They block sunlight and move water into the air through leaves. In a strange way, trees help a city sweat. Remove trees, and the city loses one of its cooling systems. That is the urban heat island effect. Same weather, same sun, but very different suffering. If you are finding this useful, please give the video a like. And subscribe to the channel if you want more simple visual stories like this. It really helps me a lot, and I truly appreciate it. Alright, now let's get back to the heat. Heat also changes food before people notice the full damage. Plants live by balancing sunlight, carbon dioxide, and water. Their leaves have tiny openings that breathe in and release moisture. When the air gets too hot and dry, plants close those openings. That helps them save water, but it also slows growth. A crop does not need to disappear to create trouble. It only needs to grow less reliably, in more places, more often. Dry soil makes heat worse because it cannot cool itself well. Rain may come too hard, too late, or in the wrong season. Farmers can adapt, but adaptation costs time, money, and luck. When crops struggle, the food system feels it far away. A hot field can become a higher price in a distant city. Animals face another kind of puzzle. They can move, but only if there is somewhere safe to move. Mountain species climb upward until the mountain simply ends. Polar species move toward cold until the ice disappears. Ocean animals follow cooler water as warm currents spread. But their food may not move at the same speed or direction. So survival is not just about escaping heat. It is about whether the whole living schedule still matches. A flower may bloom before its pollinator arrives. An insect may hatch before baby birds need food. A fish may move before the predators or prey around it adjust. Nature is not just a collection of separate species. Nature is a schedule, a network, and a long chain of timing. Heat changes the calendar underneath life. That is how ecosystems can break quietly. Not always with one dramatic disaster, but with relationships arriving late, early, or not at all. Coral reefs show this problem in a very visible way. Corals live with tiny algae partners that help feed them. When ocean water stays too warm, that partnership can fail. The coral turns white, almost like raising a warning flag. If the heat lasts too long, the reef may not recover. And reefs are not just pretty underwater decorations. They are cities, nurseries, shelters, and restaurants for sea life. When reefs collapse, many creatures lose their homes at once. Again, heat does not attack only one thing. It pulls on the connections between many things. Forests have their own breaking points too. Hotter air can pull more moisture from leaves and soil. Dry trees, dry grass, and dry soil make fire spread more easily. Fire itself is natural in some forests. But hotter droughts can make fires larger, faster, and harder to control. After a severe fire, heavy rain can wash soil away. Then young plants have a harder time coming back. This is how heat becomes a chain reaction. The same thing happens with water. Warm air can hold more moisture, like a bigger invisible sponge. So some storms can dump heavier rain in shorter bursts. Meanwhile, other places may wait longer between rains. Climate change is not simply more heat everywhere in the same way. It is more stress inside the water cycle. Too much water here, too little water there. And many human systems were built for older patterns. Roads, farms, drains, homes, and power grids expect familiar weather. When the pattern changes, planning becomes harder and more expensive. That uncertainty is part of the damage. Civilization depends on expectations more than we usually notice. We expect seasons to behave roughly normally. We expect rivers, rains, crops, and workdays to have patterns. Heat makes normal less normal. So what breaks first when Earth keeps getting hotter? Not Earth itself. Earth has been through hotter periods in deep time. But modern civilization was not built for those worlds. What breaks first is the safe operating zone. The zone where bodies can cool themselves. The zone where crops grow at the right time. The zone where reefs, forests, insects, and animals stay connected. The zone where cities can function without constant emergency mode. This does not mean every place becomes unlivable at once. It means easy survival becomes harder in more places. Walking, working, sleeping, growing food, and recovering all take more energy. More of life has to spend its energy simply coping. That is the hidden cost of heat. It steals space from normal life, and fragile systems lose that space first. The planet will not disappear. The universe will barely notice our heat problem. But life does not live across the whole universe. Life lives in a thin layer wrapped around one planet. A little air, a little soil, a little water, and a surprisingly narrow range of comfortable temperature. That range is the real treasure we often forget. Heat becomes dangerous when it pushes life outside that range. So the question is not only how hot Earth gets. The question is how fast life, cities, and societies can adjust. Some life will adapt, some life will move, some will be protected by better human choices, and some may not keep up. That is what breaks first: stability. Not the planet, but the balance life depends on. Earth is getting hotter because heat is staying longer. And the first systems to break are the ones needing balance. If you found this video helpful, please give it a like and subscribe to the channel. Thank you. It really helps me a lot.